Welcome to the last installment of Genetics with Mrs. Klein. The topic of this video is sex-linked traits. Sex-linked traits are yet another variation on Mendel's law of dominance. In the case of sex-linked traits, the alleles for these genes and these traits are located on the X and Y chromosomes, which means they will be linked to a person's gender. For the purposes of this video, we will only be looking at genes that are located on the X chromosome. One example of a sex-linked trait is the gene for color blindness, specifically red-green color blindness. The picture in this clip shows a general test for red-green color blindness. If you can see the number 5 in green in the middle of the circle, then you are not red-green colorblind. As you might remember from our unit on chromosomes and DNA, females have 2 X chromosomes and males have an X chromosome and a Y chromosome. So when it comes to sex-linked traits, women will have 2 copies of a sex-linked gene, but males will only have 1 copy because they only have 1 X chromosome. Females can have 3 possible genotypes for a sex-linked trait. We represent these traits with an X and a superscript. In this case, I've decided to use the letter H, but really you can use any superscript you want. X big H would mean that female is normal. X big H, X little h means that the female is normal, but is a carrier for whatever disorder or trait you're talking about. Again, one example is color blindness. Another example is hemophilia, which is a blood clotting disorder. A woman could also be X little h, which would mean that she is affected by the disorder. Again, either color blindness or hemophilia, for example. Males can only have 2 possible genotypes for a sex-linked trait, because again, they only have 1 X chromosome. So males can be X big H and Y, which means they are normal and not affected by whichever trait or disorder, or they could be X little h and Y, which means they are affected by this trait or disorder. It's important to note that males cannot be carriers. They are either normal or affected. Let's try an example together. In this case, we're going to cross a colorblind man with a normal female who is homozygous for this allele. Now for this, we're going to use X big B and X little b to represent color blindness. So the first thing I always do when completing a sex-linked trait, Punnett square, is to put my X and Y chromosomes on the sides. So X and Y, X and X for female. Now for man, we know he is colorblind, so he is affected, so he must have a lowercase letter. In this case, again, I'm going to use B for color blindness. Now the female is normal and she's homozygous. So that means she's going to be X big B, X big B. Let's fill in our Punnett square. All right. Now for our genotypes, we have 2 possible genotypes. We have X big B, X little b, 2 out of 4. And then we have X big B and Y, also 2 out of 4. Now when it comes to doing phenotypes for sex-linked traits, we have to divide it out into males and females. So in this case, when we look at the males, which are here at the bottom, we notice that our phenotype is normal because they both have a dominant allele. So in males, it would be 2 out of 2 normal. Now for females, we look at and they have an X big B and an X little b. In this case, they're also not affected, but they are what we call carriers. So you would say they are 2 out of 2 normal, and I'm going to put in parentheses, but they are carriers. Again, being a carrier means they do not have the disorder, but they can pass it on to their offspring. Let's try another example. In this case, we're going to cross a colorblind male and a normal female who is a carrier. So we're going to set it up X and X for my female and X and Y for my male. Now the male is colorblind, so he'll have an X little b and Y. And the female is a carrier, so she will be X big B, X little b. We will fill in our Punnett square. Now we will figure out our genotypes. So in this case, we have 4 possible genotypes: X big B, X little b, X little b, and Y, X little b, X little b, and then X little b and Y. For our phenotypes for males, we have 2 choices. We could have a normal male, which was our X big B and Y, or we could have our affected male, X little b and Y. So 1 out of 2 males are normal, 1 out of 2 of our males are affected. For females, 1 out of 2 is normal, but is a carrier. And then 1 out of 2, the X little b is affected. Let's do one last example together. In this case, we're going to cross a normal male with a normal female who is a carrier. So when we set this up, we'll do X and X for the female, and X and Y for the male. Now in this case, our male is normal, so he will be X big B. And our female is a carrier, which means she's heterozygous, so she'll be X big B, X little b. Then we will fill in our Punnett square. All right, looking at our genotypes, for females, we have X big B, X big B. We also have X big B and Y. Then we have X big B, X little b, and then X little b and Y. For our genotypes, and we have those, and then for phenotypes, remember we divided out into males and females. So I'm looking at my males. This one is normal, and this one is affected. So we can say 1 out of 2 will be normal, and 1 out of 2 would be affected, meaning again that they are going to be colorblind. For females, if we look here, this one is homozygous normal, and this one is heterozygous, but it's a carrier. So we can say 2 out of 2 are normal. We could also write 1 out of 2 normal and 1 out of 2 carrier, and that would also be correct. It's time to practice on your own. Complete pages 21 and 22 in your packet, and then when you are finished, you may check your answers to see how you did.